place the object in front of first lens such that the image of the object falls on itself. So these are lens combination given. We have an object 2 and we have lens L1. The light rays from object 2 fall on the lens L1 and then they meet at point P and then pass through the second lens, and after that they fall on the mirror M. For the image to be formed on the object, the light rays must fall perpendicular to the mirror. When they fall perpendicular to the mirror, they retrace their path back to the object. Okay, so we'll start with the second lens. For lens L2, the image is formed at infinity because they are parallel beam of rays, and then the object distance we have to find out, and the focal length is given as 10 centimeters. So using lens equation, I can write 1 by f is equal to 1 by v minus 1 by u. So since v is infinity, 1 by v is 0 and we get u is equal to minus f. So this is equal to minus 10 centimeters. So this distance we got as 10 centimeters, minus 10 centimeters. And the separation between first lens and the second lens is given as 40 centimeters. So from this diagram, if I call this as V, then we get V is equal to 40 centimeters minus 10 centimeters, which becomes 30 centimeters. Now let's do the same for the first lens. For the first lens, f is again 10 centimeters and v we obtained as 30 centimeters, and then x is taken as, u is taken as minus x. Now we substitute this in the convex lens equation, which is 1 by f is equal to 1 by v minus 1 by u, and 1 by f is 1 by 10, 1 by v is 1 by 30, and 1 by u is plus 1 by x. So this gives us 1 by x is equal to 1 by 30 with minus sign plus 1 by 10. So we get 1 by x is equal to minus 20 by 300 and x is equal to 15 centimeters. This is the distance at which the object must be placed from the first lens such that the image of the object falls on itself.